Afternoon, madam.
Hello. Okay, let's get started. So, so this week is week 11 or week 12, if I'm not mistaken. So you have two more study week. You have 2 more weeks, okay, untuk pembelajaran dan pengajaran. But I can say this is our last class, okay, last week, so that you have two like free week for you to do your revision and etc. So if you have another assignment, you have more time now. So for today, we're going to finish up our lecture 11, lecture 9, which is computer arithmetic. As for lecture 10 and 11, okay, I already upload the slide and also the recorded lecture delivered by EP Dr. Johari last week. So that please watch that video. Because 10 and 11 is quite, for me, it's quite, I think for you it's also quite straightforward. For example, lecture 10 is about computer function. So half of the slide is actually is redundant with what we have learned so far, especially in the CPU lecture. And then yang 11 too is more like to show you the different type of instruction set. That's it. Okay, so it's a bit theoretical. Agak theoretical and straightforward, but you must read it. Okay, if you still have question, you can ask me anytime. Okay, but please watch the lecture. Okay, you can tengok lah, kalau tak tengok nanti susah nak faham. You can still read it and understand it, but if you watch the lecture, so it's become more easier to you. Okay, so having to say that, this will be my last lecture with you guys for this semester. Okay, let's get started. So lecture 9 is computer arithmetic. I think we only have few more slides to finish up since last week. Okay, before we continue, okay, you can like as usual, let me do some recap with you guys. So what you have learned so far in computer architecture, firstly is to understand what are the components of your computer, what are the structure. Okay, when we talk about computer architecture, the word architecture means that what the structure made of. Macam structure rumah apa? Tingkap, dinding, pintu kan. Sama juga dengan komputer, what are the structure? So you know that there's 4 main component of your computer, 4 main structure. To build a computer, you must have this structure, this component. So you dah tahu kan, 4 component yang apa Mickey Mouse ni kan. So here you have CPU, then you have main memory, or you can call it RAM or primary memory, doesn't matter, the same thing. Then here you have I/O. Remember, it's not devices, it's a program or controller or a module, okay? And remember, they're not talked directly, so they must have a medium. So a system bus to interconnect these 3 main components. So bus make the last component. So you have 4 main components or 4 structure in order to have a computer. And also you have 4 main function, okay? Apa main function dia? Data processing, data movement, data storage and control. Okay, when you have these 4 and this component, then you have a computer. Okay, without any of this component, you cannot call it a computer. Tak boleh. No matter how smart the device is, they must have this component. Okay, this is based on the volume architecture, right? So then, so far we have learned, we have covered all these 4 main components. Okay, CPU, you know, is a processing. What are the main function? The main function is to process, to execute. What are they executing, guys? Instruction. Okay, instruction that key in by the user. Okay, and then what else? So then you learn about main memory. Okay, it's a random access. You must understand the characteristic of your memory. It's a volatile or non-volatile. So you know it's a volatile, meaning when this power is off, they will release all the data that retained dalam storage. This is a temporary storage. Once you switch on your computer, all the necessary program that need to load up, to boot up the computer will be loaded into your RAM. And also all the job, the program, the one they need to process will be loaded into RAM, including the data. Okay, so the CPU function dia apa? You know, is to process. So apa yang dia process? Instruction. Where they get the instruction from? They will fetch it from the main memory. Sebab tu ya, you tahu dia ada cycle, dia start, fetch, execute, and end. Okay, if it's a single instruction. If they have multiple instruction, we go on the loop. So what are they fetching? They are fetching data, operand or program from the main memory. Dia akan fetch from memory then brought back to CPU to be processed. Dia kena process lah. So of course dia kena via the system bus. The system bus here you have learned dia ada 3 line. They have 3 lines. What are these 3 lines? These 3 lines adalah control line, address line, and data line. So each of this line they carry different thing. Satu ni carry control. What the control is the signal. Ada read or write. Dia nak read ke dia nak write kan? And then address. Address is they need the address. So they don't know where they will get this data from or to send the data to. Okay, dia kena ada address. And this line untuk data to carry the data. Remember at this stage, bus doesn't care what inside this line. Dia boleh jadi data, operand or instruction, anything. Dia just carry. Macam bus angkat passenger lah, dia tak kisah pun awak lelaki ke perempuan ke muda ke tua ke, dia carry passenger, human. Same goes to this line, they will carry the data, any type of data they will carry. So dia ada separate lines, ada 3 lines. So they will interconnected within these 3 main component. Alright. And here you have I/O module. We have learned this last 2 weeks. So you have learned this a module is a program. So why? Because your computer system connected to multiple of devices. At least 2 kan, keyboard dengan apa mouse. At least. So you have different peripheral devices that connected your computer system. This is I/O lah. Can be input device, it can be output device, anything. So you have different type of devices, meaning different format. Betul tak? Ada different format. Dan juga dia can be from different manufacturer. So the setting is different. Also the amount of data they carry also different. Ada yang besar, ada kecil. Also the type of data. Ada audio, ada text kan, ada image. Also it's different. So different in size. So when they're transferring the data in and out, also different transfer rate. So you dealing with different types of peripheral devices. So I/O, they are not, so they need a medium here, a media here to, to synchronize the communication between I/O and CPU. So dia kena ada I/O module lah. Kat sini kalau you refer back to your slide, you akan nampak I/O controller lah. Each of these device that has their own I/O controller. It's the same meaning with the I/O program, I/O module, yeah. It's a program. So what they are doing is to synchronize the communication. Why? Tadilah saya dah list out different setting, different format and etc. So what they're doing is here is have a register. Remember, you must understand apa maksud register. Is to hold temporary data. Register they hold temporary things. So they will, let's say CPU they request. Okay, I want the request apa signal. Dia kata read, dia nak read from any of this device. They will inform I/O module. So I need to get this data from this device A. Contoh So this module will communicate with I/O to check the status first. Are they ready? Are they busy? Contoh lah. When they get the data from, let's say from here, so they will fill in the register first. It's like some sort of buffer. Bila dia dah penuh, baru the CPU will fetch the data from this register, not directly from the devices. You isi dulu baru dia ambil tu, because you want to sync the communication. Sebab often CPU is always at the faster rate. Dia selalu laju. Takkan dia nak setiap kali check kan. So it's not efficient. So they will wait until the I/O module send that signal. So it's ready. So the CPU will fetch it from this register. So while waiting, CPU can do other stuff. Remember, you wanted your CPU to be efficient at all time. Efficient means the CPU must be working at all time. Dia tak boleh idle. Kan? Faham? This is what you have learned so far, guys. So you must understand what the function of this component. Kita dah belajar dah. Empat kita dah belajar. Okay, but what we are learning in computer arithmetic, okay, last week is a component of the, belum habis kan? So dia kena ada register lah, and then what is a main memory? Can we do some revision lah? Main memory you can view is like this. Okay, saya bagi awak metaphor multi-level building, right? So in each of these, there is addressable location. So all the data, program, instruction will be stored here dalam memory line. We call it memory line. As we go, you learn about memory block dan sebagainya. So each of this line, they have their own address. They are the address starting from 0 until n. N is the end of the capacity size of your RAM. Okay. So this we call addressable location. So when the CPU they wanted to fetch instruction or data or anything from the RAM, they must know where is the location. Remember I give you the metaphor of Grab driver, Grab food kan. When they want to pick you up, they need to know where you about, di mana awak. So they need the location. Same goes to the CPU. They wanted to fetch something, they must know the location. How they know? They will refer to the component. Ni you dah belajar juga. Remember you have PC counter, you have instruction register. So they will refer to this register. This register will point to the address inside the main memory. So they will go to the specific line to fetch the data and brought it back to CPU to be processed. Okay. So then you dah belajar lah macam mana dia masukkan data ke dalam RAM. So what algorithm they are using? Let's say it's all occupied, dah semua dah penuh lah ni. So there's a few methods, first in first out ke, least recently used ke, macam tu lah. So the CPU, here you learn about the inside the CPU itself, there's another component, banyak komponen ya. Dia ada program counter, instruction register, memory address register, memory buffer register, banyak, okay. But they also have the another component, the ALU. Inilah arithmetic logic unit. Dan dia ada CU, control unit, they have a register here. The many type of register. So arithmetic logic unit ni actually performing the arithmetic or logic unit, logic operation. Yang ini yang kita belajar computer arithmetic ni is a part of the ALU. So what is our aim to learn, to discuss this lecture for you to get your understanding of how your computer perform mathematic operation, arithmetic operation. Macam mana dia perform arithmetic operation tu yang kita nak belajar for us to understand how our computer works. Because they're only dealing with binary kan, satu dan kosong. Kan, they only deal with 1 and 0. How they do it? Okay, for example, if you are like human being, if I put 3 plus 2, you know, 3 tambah 2 is 5, right? So dalam math, dalam komputer macam mana they need to translate is to the binary number. The binary number, then they will do the addition. That's how they work. They need to convert into the binary format dulu. What about if there's a sign magnitude? Okay, ni yang last week ada tanda sign lah, negative. Macam mana dia tak tahu ni negatif? Kalau sign magnitude dikata 0 is positive, 1 is negative kan? So kalau dia buat math macam mana kalau ada negative sign? So ini yang kita dah belajar last week. Okay, you have learned this last week. Kalau 3 plus 2, you know it's 1, right? But how computer does it? Macam mana computer buat ni? Macam mana dia text this value? Ni yang awak dah belajar last week. You will learn about 2's complement. So they will do this operation which is step 1, step 2. Step 1 apa? Step 1 you do the NOT operation, bitwise NOT operation. What is NOT operation? If 1, you invert to 0. If 0, you invert to 1. Simple as that. Then what is the step number 2? The step number 2 is you add 1 bit to least significant bit. What is the least significant bit? Katakan ni bit awak ada 4 kan? On the far right, ni dipanggil least significant bit. Your far left is what we call most significant bit. Okay? So the step number 2 is to add 1 bit. 1, 1, 0, 1. Then this value is a negative values. Kan ni je senang je. This is the essence of it. Okay, let's continue. Let's pick up where we stopped last week. I think it's slide number 13. 13 ni ya. Saya tak akan ulang balik saya dah ulang sejak tadi. So what you need to do is to understand how its algorithm work. Senang je by reading this flowchart, or you can based on this some sort like pseudocode lah. They explain of how this algorithm work. This is the best on both algorithm. Last week, there also example of multiplication. Okay, kalau dia buat multiplication macam mana? For example paper and pencil. Kalau you buat dalam paper and pencil, this is how you do it. Kan, yang you belajar kat sekolah dulu kan. So let's say you have 4 digit. So this is a multiplicand, this is a multiplier. Okay, is a multiplier. So kalau paper and pencil, macam mana kita buat? 1 darab 1 kat sini dulu. Okay, lepas habis 4 digit, then you shift to the left. Kan dia akan satu darab kosong. Second cycle kan. So you're done with this, then you move here. Then you have third cycle, then the last one, 1 times 1, 1 times 1, 0 times 1, 1 times 1. So this is a fourth cycle. So the number of cycle depending on number of multiplier. 4 multiplier, 4 cycle. 2 multiplier, 2 cycle. 3 multiplier, 3 cycle. Faham tak? Tekan ada 3 je. So 1, 1, 1 kan macam ni. Matematik biasa ni. Ni yang kita buat macam biasa. Okay, you buat benda ni macam biasa. Macam you biasa buat, cuma apa yang kita nak belajar, macam mana komputer buat. Itu je. Kita want to understand how computer do it, the arithmetic operation. So now, kita sambung untuk, ni dah last week. In this week, you tengok both algorithm pula. Both algorithm involve how many register? A, M, and Q. Okay, while I'm explaining this, I want you guys to keep on looking at the slides. Yang ni penting lah. So you follow benda ni saja. As long as you know what it mean, then you see. So multiplier is loaded into register Q. Multiplicand is loaded into register M. So you kena tahu lah which one is multiplicand, which one is multiplier. Okay, dekat sini ada tunjuk lah mana satu multiplicand, mana satu multiplier. Okay, and then what? And then okay, register A is initialized to 0. Register Q minus 1 bit is initialized to 0. So altogether you ada 4 register, 4 register. So you need 4 register, which is Q, M, A, and Q1. Initial value of A is set to 0. Initial value of Q1 is initialized to 0. So only you loaded the values. And what need to be done? Dia kata the control logic scan, arithmetic logic operation. Control logic will scan the bits of the multiplier 1 at a time. Ni yang saya katakan tadi, bila you ada 1010, 111, this is multiplier. This is multiplier. So dia akan scan 1 bit at a time. Lepas sini, you shift to the left, shift to the left, shift to the left, then you're done, alright? So then what? Then it give you this condition. So you have to observe this condition. If they met this condition, the algorithm will do like, if you do this, else you do this. It's like, you know, the condition, kalau you buat algorithm, if Q0 in Q1 equal to 1, 1 or equal to 0, 0, all bits of A, Q, and Q1 register shifted to the right 1 bit. Kalau condition dia 1, 1 or 0, 0, okay, bit dekat register A, Q, Q1 will be shifted. So apa Q0? Q0 is the bit position at 0 of Q. Ni Q, okay? Yang Q1 ni you initialize. So if the condition is 1, 1 or 0, 0, so A, Q and Q1 will be shifted. Kalau tak, if, dia kata dia akan bagi condition lain pula. If Q0 and Q1, Q0 is 1, 0, Q1 is 1. What need to be done? Is added to M. Multiplicate is added to M. So you need to do the add operation. But if, ini dia punya if, kalau Q0, Q1 is 1 or 0 terbalik, you need to subtract from A. So, okay. Ingat, saya kata kalau komputer you nampak sign negatif ni yang dia kena buat to complement tadi tu. Okay. And then lepas ni dia buat apa? Then after dia done either 01 or 10 ni, dia akan right shift what? A, Q and Q1 to the right, okay? And then they do the sign preservation, shifted and remain in A, count lah N minus 1, okay. Kalau you perhatikan ni, senang je. Okay. I hope you guys follow, it's easier. So ni condition dia, both algorithm, if Q0 position 0, ni dia loaded, this is the multiplicand, this is your multiplier. So this is the first step, so dia akan load into the register. So the initial value of M is 0, 1, 1, 1, multiplier is 0, 0, 1, 1. Then for A and Q1, set to 0. Okay, set to 0. And then baru you buat algorithm. And then you kena observe. Dia kata apa? If this is the condition. This is the condition. Dia kata if Q0, Q1 is 11 or 00, what need to be done? Apa kena buat? Okay, kena shape kan. Lepas tu dia tengoklah. Q1, Q0 kan. This is a bit positioning. Ingat kan kalau kosong, 1, 2, 3. So Q0 is here. So now you Q0 apa? Q0 1, Q1 kosong. Kena buat apa? 1 kosong. Tengok kat sini. 1 kosong. Oh, you kena subtract. Apa yang kena subtract? A minus M. So you kena buat subtraction. Remember, subtract macam mana you nak minus. So apa value A awak adalah 00. So value A, value M, oh saya tak boleh terus ni. Tak. M apa lah? 0111. Kita nak buat operation subtract ni dah belajar. So you buat subtract. Sebab ada subtract, komputer tak boleh baca. Bukan dia tak boleh baca, dia tak boleh take in the negative value. So dia akan buat the two's complement. Okay. So you kena negatifkan value ni dulu. 0111 ni. So first step tadi apa? First step not operation, invert saja. So 1 0 0 0. Second step, add 1 bit to the least significant bit. Tambah 1. So baru you buat operation A tolak M. So ni value baru awak untuk M. Ini dah negatif M lah. Ini positif M lah. So you do the operation. So 0 0 0 0. Ambil ni 1 0 0 1. Then you do the adding. 1 0 0 1. Anak panah ni maksudnya store dekat A. So value ni masukkan dalam register A. Here you go. Bila you dah buat subtract, ni. Lepas tu dia kata apa? Lepas you subtract, you kena tengok condition apa you kena buat. Kan, kalau you dah buat either two ni, you need to right shift. What need to be shifted? A, Q and Q1. Ke mana? Ke kanan. So, shift to the right. Shift to your right. M tak? A, Q and Q1 only shift to the right. Yang hujung ni tendang je lah. So, shift, 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 shift. Then you shift to the right. Alright. Tapi dia kata preservation of the ni. Find preservation A is shifted and remain in A. It's copied to A and must not move. Saya tak boleh move. Sebab tu you tengok ni, even though you shifted to the right, by right dia jadi kosong kan, bila dia shift kan. Tapi dia panggil preservation. Find preservation. So it's not move. Ni, self-preservation, shifted and remain in N minus 1. Okay? Dan seterusnya. Boleh faham tak guys? Itulah saya, kalau saya teruskan lagi tak ada suara ni. Boleh faham tak? Yang boleh faham, yang boleh faham. Yang sebenarnya, what you need to be aware is if you saw this negative sign. Ni sahaja. At the moment you nampak ni, you need to do the two's complement. Yang two complement. How you do the two complement? Involve step 1, step 2. Step 1 you invert saja, not operation. Sebab tu you belajar digital, basic digital logic. Kalau 1 jadi 0, 0 become 1. Then after that you add 1 bit to the least significant bit, paling kanan. Then voila, you get the negative values. Lepas tu you kena ikutlah apa dia kena buat shift. Macam contohnya yang cycle, second cycle ni. Look at this Q0 and Q1, this condition. So Q0 value dia 1, Q1 value dia 1. So what need to be done? Tengok 1, 1. Tengok kat sini. Oh, 1, 1. So ini dia punya ni. So apa kena buat? You refer back here. Q1 is 1, 1 or 0, 0. All bit shift. You kena shift saja. Tak ada addition or subtraction. So shift to where? Shift to the right. Shift ke kanan. Ini both algorithm shift tu ke kanan. And then ulang balik. Boleh faham tak? Kalau boleh saya tak payah sampai habis lah. Gatal tekak saya ni. You guys understand? Good. Siapa tak faham boleh tanya Venorika lah. Ataupun tanya Kevin ni, boleh tanya. Tapi senang kan? You must be alert with that negative sign. That's it. Kalau ada ni tukar sebab dia tak boleh baca negative sign tu. So they need to do the operation first. Call it two's complement. Okay, and then the rest you just follow. And the result will be stored in A and Q. Okay, ini Bose algorithm. You can compare with the previous algorithm. Macam mana dia buat? Previous algorithm ni dia guna berapa register, just a different type of register. Okay. Okay, moving on. Saya skip sebab dia berulang je. Sebab nak tengok division. Sama juga for division, this is how you do it. Kalau you guna pen and pencil lah, but how computer do it. Macam mana komputer kita buat? Sama juga, dia akan tengok balik condition. They give the condition. So they're using this unsigned binary division. So here you can see A, M, and Q. So only 3 register. A, M, and Q. A will be initialized to 0. M is the divisor. Q is the dividend. So count is N lah. So this is the condition. First, you need to shift to the left. What need to be shifted? Bit 1 at position 1, A and Q. Register N and Q only. After that, do the subtraction. Kalau you nampak subtraction ni, you nampak je negatif M ni, then you must do the 2 complement. Okay? Buat 2 complement. Okay, dia tak faham. Komputer ni tak faham. Okay, then lepas tu dia akan check the condition. A, okay, ni kan tadi dah A initialize 0. If your A is 0 or your A is 1, do what? You kan tengok sini lah. Kalau dia no, dia akan initialize Q0 to 1. If yes, do this operation. Dia bagi you condition and you need to look at the register. Also at the certain bit positioning. Okay, macam ni lah. Sama. It's up to you. They give you 2 representations, satu flowchart. Some people they prefer to look at the flowchart. It's clearer to them. And some people they prefer to have like some kind like pseudocode style. But both is the same thing, Both is the same thing. Because if the sign A is not the same before and after the operation, A is not equal to 0, then Q 0 is equal to 0 and restore the previous value of A. You kena ikut je ni. It's a basic algorithm. Boleh faham tak guys? Kenapa dia tak ada contoh? Ni contoh dia. You boleh try. You can try the contoh here. Ni dia kata, first ada 3 register je. Untuk division only have involve 3 register, A, Q, and M. So A, this is the initial value. Masa mula-mula sebelum run komputer waktu. A adalah 0, 0. Q is dividend. M is the divisor. So, dia kata apa? Shift. The first operation is shift. Kita tengok ni sama je. Shift what? A and Q left 1 bit. Shift to the left 1 bit. So, to the left. By what? 1 bit. So dia akan shift lah A and Q ke kiri. So tu yang nampak yang berubah ni. Bila dia shift ke kiri, ni akan jadi kosong lah. And then do the subtract. Then subtract what? What need to be subtract adalah A minus M. A. Kalau nak pandai ke A, maksudnya you store to A. Okay, let's say contoh lah, I put like this, contoh meaning you store to M. Itu maksud dia. So A minus M. The moment you saw minus kat sini, kan sebab M ni positive value tau. M is the positive value. You can consider M, D is the positive value. Now you need to have negative value of M. How? Do the 2's complement, involve 2 step. Okay? Then you buat addition macam biasa. Okay, lepas subtract you kena buat apa? What need to be done after you do the subtract or addition? If the sign kata, then you kena perhatikan observe the A sign. Kalau sama before and after, then A is equal to 0, then Q is equal to 1. If not the same, you do this. So they give you condition. Okay, then you can buat je senang je. Boleh tak? Ini dah terlekat dah. So then you restore. Restore to where? Restore to A lah yang ni. Sama sahaja macam previous one, just like this is the division. Jadi it's a division. So involve only 3 register. Okay, then you have to observe the A and Q. Q0 and A punya sign value. Sini ya. Then you will get this A will be the reminder, Q will be the question. What I want you to do is, okay, without you buat ni tanpa tengok jawapan ni dulu. If you get the same thing, then it's correct. The important part is for you to able to understand to follow this algorithm. This is very basic sebenarnya. Kan you done your introduction to programming already. So algorithm is a step of instruction. Kan dekat sini involve a few condition. If this happen, do this. Macam tu. If Q0 is 1, if Q1 is 0, do this. Macam tu. Tapi dia main thing dia ada A minus M ni lah. A minus M when you see the negative value. So computer dia tak baca negative value ni. So what you need to do is you do the 2's complement operation. Okay. So lecture 9, the lecture note is quite bagus, sangat bagus lah. This very clear. Very clearer and then compact lah in how to do this. Alright. Boleh faham kan? Senang kan? Walaupun senang, dia senang lupa. Percayalah cakap saya. What you need to do is, after this, you kena buat latihan ni balik. You buat balik benda ni. Kan? You buat balik benda ni. You don't refer to this slide. You ambil C, A, Q and M ni. Only you write it down and try to do the operation. Then cross-check your answer whether you have the same steps with this answer. When you do this, just refer to the pseudocode or flowchart. So tengok macam mana, boleh faham tak cara nak follow flowchart. Flowchart ni follow satu-satu je because algorithm is a step of instruction. Step 1 do this, step 2 do this, and then the certain condition is set. Okay? Boleh kan? Itu sahajalah guys. Kalau tak ada soalan, senang je. Tapi you need to do exercise. Just do exercise from this lecture, not that enough. It's enough. Okay, you repeat, you copy back all these values, then try to do it using a pen and using your manually lah, then you compare your answer. Okay, then sambil you buat ni, you refer je lah kepada pseudocode ni. Okay, to latih you to read this. This is how you do programming actually. When you do coding or programming, that's why your step of algorithm is very important. When you want to, let's say you want to create any algorithm kan, you want to create your own algorithm, you must, sebab komputer ni dia tak faham kita, so you have to be very specific with your instruction. Okay, if this condition, do this. If else, do this. Else, do this. While, do this. Sebab komputer, you have to be specific with them. Manusia lain, manusia ada insting, komputer tak ada. Macam awak ask go to the cafe kan, I want you to buy me chicken. Kalau komputer kena cakap chicken curry ke, chicken goreng ke, chicken whatever chicken lah. Kan? Kalau tak dia pergi exit the loop, dia tak beli apa-apa. Kalau manusia kan, awak chicken, awak pandai tukar pula. Macam chicken curry goreng tak ada, tapi ni ada nugget pun goreng you boleh beli. Macam tu lah, manusia is more smarter than computer lah. Computer have to be very specific when giving them instructions. Sebab tu dia set all these condition. Boleh faham tak guys? So you kena able to read the, macam ni dah ada algorithm ni dah betul dah. You just must be able to read the algorithm and implement it. Itu saja. So that's computer arithmetic. What our goal from this chapter is for us to understand how our computer do the arithmetic operation. Macam mana dia buat arithmetic operation yang simple arithmetic operation lah. Subtract, addition, multiplication and 3 tu lah. Kan? Dan kalau ada negative value, how dia turn the value from positive to negative. Macam tu sahaja. So they involve a number of register based on what algorithm they are using. Boleh faham? Senang je kan? Sebab tu you kena faham apa you belajar. Jangan hafal tak boleh jadi. If you understand then it's easier. Okay? Macam manusia kita belajar 3 plus 2, 5 sebab when you are small, very small, you learn using your fingers. Itu kita panggil machine learning. Ini macam machine learning lah. You train dari kecil, ini hijau, ini biru, ini biru. Bila you dah besar, you tahu. You pejam mata sebelah, you tahu tu warna biru. Betul tak? Kalau machine, you kena train them. Itu yang machine learning, deep learning. You heard about machine learning, right? You know what is machine learning? Tahu tak machine learning? Nanti you buat FYP nanti, final year project. I heard of it before. So machine learning is basically you train the machine to become smart, literally lah. Maksudnya, katakan you ada machine, komputer kan, then you ada kucing. Kalau komputer tu dia scan ekor kucing, that's a tip of the cat tails, they can know straight away this is a cat. Macam tu. But how you want to train this computer? By feeding up banyak images of the cat. Cat berdiri, cat tergolek, banyak. So you have to train them with like a very big data images lah. Kalau kita manusia, the machine learning is inspired from human lah. Sebab masa you kecil, you tengok kucing kan, dari kecil kan. Siapa tak pernah tengok kucing? Pernah kan? Dari kecil you tengok kucing, from far you know it's a cat, betul tak? Sebab you have the data inside your head. Walaupun you tengok kucing tu ada 10 tahun yang lepas, dari jauh you nampak whiskers, you know that's a cat. Ular lah, ular tak ada whiskers kan. Sebab machine you need to feed them with the data. So dia kena belajar. Even dia tengok shadow kucing tu, dia tahu dia is a cat. Kalau manusia tak payah pun. You dengar bunyi, you tahu tu cat. Because we have trained from kita young age and our environment. So somehow it's stuck in your head. Sebab tu dah you ada permanent data dalam kepala awak. Itu machine learning lah, machine learning. Computer you have to train them to become smart. Sebab bila dia tengok dia tahu ni kucing ni bukan dia tak, because cat dengan tiger is very similar. Machine cannot differentiate if you not teach them to differentiate cat and tiger. Kan? Tapi awak boleh bezakan cat dengan tiger kan, kalau I put side by side, you know which one is cat, which one is tiger. Or your girlfriend next to it. Mana satu. Kan? So macam tu lah, that's how you train. My point is that your computer, they need instruction from us. Same goes to this arithmetic operation. Dia dah ada set condition. So kalau dia nampak 3 tolak 2, they will do this operation. Kalau 3 multiply by 2, they do this operation. They convert to binary first, and then they create a register, then blah blah blah, and then they get the answer. Macam kita manusia tak payah lah awak convert ke binary, awak guna decimal tu dah cukup. Okay guys, I think that's it for today. So this will be our last class. So to finish up 10, 11, please watch the videos and it's easy to understand, I do believe, but you must watch the video. The last two parts straightforward, but if you're still having a problem to understand or anything to ask, please email me. Okay, so I will try my best to reply to your email as soon as I read your email. Kalau terlambat tu sabarlah, tapi kalau dah 3-4 hari tak balas, you can email me again. But usually I will not do it purposely, tak balas email pelajar. Okay. And then your final exam will be on 14th of July. Okay, remember your final exam ada 2 part, part A and part B. For part A is a take-home exam. So the question will be released in week 14, which is 2 weeks from now. So you're given 5 days to complete it. It's just a reflection question. So we give you a few questions. So you need to answer to the question accordingly. So you answer and then submit by Friday on week 14. Remember, there's no extension will be given. So please allow yourself at least 1 hour before the deadline. Jangan tunggu dah 5 minit. So I will, like I said before, I will activate the link at least on Thursday. I don't want to activate it earlier because I don't want students to send their answer, then they change their mind, they want to card. No, I will send it as early as Thursday, hari Kamis. So you can, if you feel you want to submit your answer, then you can start submit it on Thursday, but not earlier than that. Once you submit it, you are not allowed to resubmit. For whatever reason, you tak dibenarkan. So make sure before you submit, you are happy with it. You then check whether you send the correct document or not. baru you hantar. Okay? Itu untuk part A, dan part B will be the MCQ online exam will be on 14th of July. You can refer to the schedule lah. As for your carry mark, I will try my best to release all the carry mark by week 15, which is a study week. Alright? Jangan tanya lah mana carry mark, I will release on study week. Kalau saya dah siap yang untuk assignment, I will release it earlier. Okay? What else? I think that's it, guys, from me. So I hope to see you guys next semester. I'm not sure whether I will handling operating system class or not. If not, I will see you around the campus lah. And having to say that, QR code boleh. I wish you guys all the best in your final exam, not only for this course, also for other courses. Okay, I hope you can score a good grade for CA. Most importantly, to have a good understanding of this course. From that, okay, I would like to, if I do have said the wrong thing, did the wrong thing, so I apologize. Okay, kalau saya masuk lambat, kadang-kadang tu masuk lambat, I lupa nak announce, lupa nak ni, I apologize for that, and I'll promise to improve for the next semester. And you guys pun kena belajar rajin-rajin, and please take care and best of luck in your exam, okay? Siapa tak boleh scan, you can leave your metric number. For those yang dah scan, you can leave the session. Okay, welcome guys. You jangan tak tengok video last sekali. Okay, I will keep this on for maybe 5 minutes before I end the session, ya. Siapa tak boleh ni letak ni nak punya metric number. Saya nak cakap lebih lagi tapi tekak sini gatal pula.